So microplastics are plastics that are smaller than 5 millimeters in diameter. So you can think about basically an eraser on your pencil that's about 5 millimeters across, so anything smaller than that. And what happens is larger pieces of plastic that end up in the ocean, as they're sitting there and being knocked around by the waves and salt water, and the sun is basically shining down on these plastics, they become very brittle and they fragment into these smaller pieces. So it looks like they're breaking down, but what's actually happening is they're just fragmenting into smaller pieces. There's no loss of material there, they're just sort of fissuring and cracking. So what happens is over time, we start to get a large accumulation of these microplastics. And since plastics have been around for about 50 to 60 years commercially, what we're seeing a lot of in the oceans right now is sort of remnants of microplastics that are broken down from larger pieces that were dropped 10 years ago or 5 years ago or even last year, etc. And these microplastics are sort of really dangerous to marine life because they the smaller they get, they start approaching the size of particles that are naturally in the water that fish and oysters and mussels and basically everything, filter feeding organisms, prey on. So they get down to about the size of plankton. So a fish isn't able to discriminate the difference between a small microplastic particle and a plankton that it's normally going to encounter and eat in its daily life. So as a result, they're being ingested. They basically clog the systems of these organisms. And if you can also imagine that eating plastic is bad because there's no nutritional value to it. So organisms that are eating plastics are becoming full, but they're not getting any energy from eating these particles. So this reduces their ability to reproduce and increases the stress that they have sort of going about their daily activities.
And then in the mid-1980s, some of our scientists that were out there started noticing, we tow this net called a Newston net every day, and it's meant to sample the plankton communities that are living at the surface of the ocean. So we can study the different zooplankton, the abundance, and the diversity. And then with that plankton net, they started noticing little bits of plastic that were mixed in with the plankton. So, realizing that it shouldn't be out there, they started to quantify it, add it to our data sheets, and keep track of it and actually save all the samples as well. So we have this pretty massive data set going back to the early to mid 1980s, covering the same cruise tracks, the same locations year after year, and using the same sampling method. So we have, I think it's over 12,000 sampling locations now. Wow. all over the oceans of plastic that we've collected, or at least where we've towed the net. There's not always plastic. And so a lot of them are in the North Atlantic, from like New England down to the Caribbean, some over to Europe and into the Mediterranean, and then we have our Pacific ship that sails from like Hawaii, Fiji, New Zealand, down there in the South Pacific.
So my work is looking at microplastics and trying to figure out how to invent tools to make it easier to sample microplastics in the ocean. So the way that it's done right now is with these microplastics, we just drag a plankton net through the water, and as a result, we bring the plankton net back up on deck, and then we look under a microscope and sit there with tweezers, and we individually pick out microplastic particles and separate them out, and then we bring them back to the lab and see whether or not they're microplastic and do size analysis and those kinds of things. So it's really tedious and just a real pain to do these microplastic studies. And there's a lot of human error that's incurred when we do these studies because it's sort of just visually separating out microplastics. And so a lot of microplastics are missed, and a lot of them are falsely identified. And as a result, there's a lot of error. So what I've been working on the last few years is creating sensors to help us quantify these microplastics in the water, but doing it completely automatically. So taking that human error out and sort of leaving it up to machines that do it the same exact way every time. So you see these two sensors. This is basically the submersible unit, and this is the benchtop unit. And they're called manta rays, I guess. And the goal of this is to just create a system that can analyze the water for these microplastics. So it uses an optical technique and is able to distinguish these microplastics from other particles that are in the water. So I've been developing this over the last couple of years, and I'm hoping to commercialize this next year so we can sort of mass deploy these and bring them out on ships that are already going out in the water and just collect underway data about the concentrations of microplastics. The reason that's important is because these studies are so hard to do on these microplastics currently, we don't have a lot of data overall. So having more data helps us to better manage the problem and get a better sort of baseline understanding of the levels of microplastics in different areas.
My colleague, Kara Lavender-Law, who's my boss that I work with here, she's published a lot of papers using this data set, so you may have seen them out there. There's one about the distribution in the North Atlantic, one about the distribution in the Pacific, where you start to kind of put all these points on a map and see the hot spots and where's all the plastic accumulating. And you start to get that picture of, the ocean gyres and where the currents are moving the plastic and where it's starting to accumulate. And that's, we've probably heard of the term garbage patches and heard that terminology in the news. And so these papers kind of showed that, yes, there's a place plastic is accumulating based on the ocean circulation, but while you're actually out there, you don't see it. It doesn't look like an island. You can't just go walk on it and scoop it up. I mean, it would be nice if you could, because it would make it a lot easier, but you can't do that.
Many of the plastics are slightly buoyant, and so they don't sink in the seawater. They just float around more or less neutrally. And many of the plastics degrade very, very slowly, or if at all, and therefore they may get mechanically torn up into tiny little bits, just a few millimeters or centimeters in size, but then they just float around in the ocean for quite a long time without being removed. And so there's something that's been referred to as the North Pacific plastic patch, where you can take nets, the kind you would use for catching plankton in the ocean, and drag them through a large volume of water, and then you find that in amongst the plankton there are bits of plastic, and it's been quantified and published in journals how much that is, and the highest concentration is found to an area that's north and east of Hawaii and off of California to the west. This is projected to increase maybe by a factor of 10 in the next 10 or 20 years. So while at this point, it's not like if you're sailing on the ocean, you're not going to see those little bits of plastic. They're very dilute. But nonetheless, turtles are eating them, albatrosses, seabirds end up eating these bits of plastic, and some of them die because of getting it tangled up in their stomachs.
One plastic that tends to be pretty not great is polystyrene, so that's recycling code 6. That's one I would say to avoid the most, styrofoam in that form. So polystyrene kind of has two forms. It can either be completely solid, so that's usually like a clear, hard plastic that breaks really easily. So you may have gotten like a takeout container that is just super brittle. That's usually polystyrene, something that just kind of shatters. Or it can be in the foamed version, like styrofoam or expanded polystyrene. Styrofoam is actually a trademarked name, but expanded polystyrene, which is like takeout containers and Dunkin' Donuts cups and all that kind of stuff. And that one tends to not be very recyclable, just because there's so little material for the volume, because there's so much air in it. And it tends to break apart pretty quickly because it's so, brittle, and it's just a lot of air bubbles, so it breaks apart really quickly, which means it's turning into microplastics pretty quickly. It also, because it's so light, can be taken by the wind pretty easily. So if it's, sitting at the top of a trash can or, somewhere where it shouldn't be, it's more likely to just be blown away and end up in, in the environment somewhere. Really not a lot of redeeming qualities of polystyrene foam, so I think that's one that is best to try to not use. With our restaurant partnerships here in town, that's one of the things we ask them to do, is not use any styrofoam in their business and their takeout containers. So we've actually none of the restaurants in Woods Hole use styrofoam. What else to avoid? It kind of depends on if there's another avenue for it. So if it's something that's easier to recycle, is better than something that you can't recycle. We found that people tend to, they like to be kind of with the crowd. So if they see something that a lot of other people are doing, it tends to take off a lot quicker. So if they see all of their friends are using reusable coffee mugs, they might be more likely to use a reusable coffee mug. So kind of that power of social suggestion, that's what everybody wants to do.
The longer that these microplastics are in the water, the more and more toxins they absorb from the water around them. So in basically most water systems around the world, there's trace amounts, small amounts of organic and inorganic pollutants that are sort of circulating around at these trace levels. But these plastics act like a sponge for these pollutants. So the longer that they're in the water, the more of these pollutants they collect and that they absorb them onto the particles. So the older the microplastic particle, basically the higher dose of these sort of other chemicals that are associated with the water around them. So things like PCBs and DDTs, we find them up to 1 million times greater concentration on microplastics than we do in the surrounding water. So we talked about ingestion. So every time a fish or plankton is ingesting a microplastic, now it's also getting all those other associated toxins. So there's a lot of work being done right now to try and figure out, are these toxins then moving into the tissue of these organisms, and then is that eventually biomagnifying up to us and ending up on our food plate, ending up on our dinner plates. So if plankton and small fish are ingesting these particles, then by the time it gets up to the apex predators like tuna and we go and eat our sushi, we might be getting these associated toxins as well. That's a kind of paramount concern to us as the end consumer of seafood. So I like to tell people to think a lot about their plastic consumption. Recycling is good, but unfortunately a lot of the plastics that get recycled don't actually end up being turned into another product again. They're either sent to landfill because they have food waste on them, or they're not clean enough to go into another product. So although recycling is good, I think you need to go one step up and think about your plastic consumption from the start. So things like single-use plastics, I know everyone's heard this a million times, but basically the things that you use for 10 seconds, your water bottles and your coffee cups and straws and basically anything that you use one time and then throw away, if you can just sort of try and cut those out of your life, it actually goes quite a long way. Things like reusable silverware, things like that. I also am encouraging people to do beach cleanups, because everything that ends up on the beach will probably end up going back out into the ocean at some point. A storm comes along and basically grabs all that material and brings it back. So if you can grab it on the beach before it makes it into the ocean, it actually goes quite a long way in preventing these microplastics from forming. So I encourage you to do beach cleanups, or just if you're on the beach in the summer, just try and leave with more trash than you came with, and make sure that you don't leave anything behind. And if we were to do that on every beach in the world, I think it would go a long way for preventing plastic getting into the ocean in the first place.
Why do it? There are alternatives that achieve the same purpose without resulting in this rather long-lived plastic pollution that could be around for centuries or longer. I think most of the plastic that, say, is in the plastic patch is not the microbeads. It's from little bits of plastic that have come out from the land, either from garbage dumps where the wind has blown plastic out in the ocean, or, coming down with rivers stuff people have left on the beach. And it certainly makes sense not to take things that, like these very lightweight, non-recyclable plastic bags that are just picked up by the wind and blown large distances. It makes sense to get them off the street. And it makes sense for people who go to beaches to clean up after themselves, or maybe some of their fellow human beings, just out of, good faith, to eliminate it, and certainly to adopt government practices of garbage collection and disposal that minimize the amount of plastic going into the ocean. First, we need to have education to teach people of the consequences of their actions. That, in many cases, people just don't believe that what they do makes any difference. And as I said, we can see the human influence everywhere we go in the ocean. So, education to let people understand, the consequences of their actions. Obviously, you see dead birds from having eaten plastics, or whales tied up in ropes left by fishing activities or ships. People don't like to see that. Most people, do react to understanding it. So let's educate people on the consequences of what we're doing. Obviously, governments, cities, towns, states should adopt efficient procedures for dealing with their trash and making sure it doesn't end up floating into the ocean. And you can pass laws. For one point, Singapore banned the use of chewing gum for some reason. Governments can take these actions if the leaders feel that it's justified. I think maybe one thing to emphasize is that a lot of the science behind things we've been talking about is very recent. Many of these things were not known 10 or 20 or 50 years ago. So we need active scientific research on the Earth's surface environment and how to understand that these things are happening and what their consequences are. And that's part of the solution to dealing with you. First, you can't solve a problem unless you know you have the problem. As I said before, and you've just emphasized, education of the people of the world is very important so that they know what they're doing and believe that it's so. I think part of the problem is there's so much disbelief that people are able to have such a huge impact on the natural environment.
And we try to base it all on social science research, so looking at kind of behavior change science and how do you actually get people to start to make a change in what they're using and what they're doing, so that we can make as big of an impact as we can.
I think you want your video to be more than just informational. I'm assuming you want it to inspire people to act. We got to get it off our beaches and out of our oceans. We've got to stop creating it, and because it's a thing that we use, and I don't think we talk enough about the amount of plastic waste that is generated in it.
To me, the most shocking thing is how pervasive it is. That you really would have a hard time going anywhere in the ocean and not being able to find some indication of the human impact on the chemistry. Maybe not in all the tracers in all the places, but you'll find nuclear fallout at the bottom of the deepest ocean trenches. You'll find it in the bottom of the ocean in Antarctica. So it's that humans are an active force on the face of the Earth now, and we're affecting everything that's accessible to the atmosphere and ocean.